In this video, I'm going to talk about acids and bases and how they interact in neutralization reactions. So acids and bases are compounds that have particular properties when they are in aqueous solution. Acids want to donate a hydrogen ion, or just a single proton, and bases can accept that hydrogen ion. We use the pH scale to measure the amount of hydrogen ions. So a pH that is less than 7, smaller numbers, is an acid. The smaller the number, the more strong the acid. A pH greater than 7 then would be a base, or it's also called alkaline. And then a pH of 7 exactly would be considered neutral. Along with the ability to donate or accept a hydrogen ion, acids and bases have other distinct properties. Because they both will form ions, they are both electrolytes. That means they can allow an electric current to flow through the aqueous solution that contains that acid or base. Acids will taste sour to our tongue, and we actually like a little bit of acids in many foods. Both fruit juices and sour candies and things like that are due to the acid content. Acids turn blue litmus paper red, and acids we already know will react with certain metals to produce hydrogen gas in a single replacement reaction. Acids can be neutralized with a base, that is, create a neutral solution when they are combined in the right proportions. Bases, along with being an electrolyte, will taste bitter on the tongue, and we really don't eat that many foods that are high in base. Our bodies do not tolerate alkaline materials very well, but that bitterness is contributed by a compound that is a base. Bases will turn red litmus paper blue, and bases feel slippery on the fingers because actually the base is reacting with a little bit of oil that's on your finger and making soap, because soap is actually an acid and base reaction, not to make a neutral compound so much as to make soap, but we feel that slipperiness if we have a little bit of base on our finger. And then, of course, bases can be neutralized with an acid. There are some rules for naming acids. All acids formulas will start with that hydrogen, that thing that is donated that makes the compound an acid. So, for example, HCl is hydrochloric acid and H2SO4 is sulfuric acid. And then the rules for naming the acid depends upon what kind of anion or negative ion follows that hydrogen cation, the positive hydrogen ion. If the acid is only made of 2 atoms, so it's known as a binary acid, you have your hydrogen plus some sort of "ide" ion, the name of the acid would be hydro plus the name of the anion and "ic." That's where we get the hydrochloric acid from HCl, hydrogen and chloride. So hydrogen and fluoride would be hydrofluoric acid, and one of our few polyatomic ions that is an ide, cyanide, carbon nitrogen, will be hydrocyanic acid. Most of our acids, though, are made of are known as an oxyacid because they're made of a polyatomic ion that contains oxygen. Many of our polyatomic ions contain oxygen. So if the polyatomic ion name ends in 8, the name of the acid will be that ion name plus an "ic" acid. So H2SO4 has a sulfate ion, that's what the SO4 is, and so it becomes sulfuric acid. HNO3 has a nitrate ion, so it's nitric acid. And H3PO4 has a phosphate ion, but we actually call it phosphoric acid, so there's a slight name adjustment using phosphor as the prefix instead of just phos. If the polyatomic ion ends in ite, that's the other category of oxyacids, then it is the ion name plus the OUS type of acid. So H2SO4 is sulfuric acid, but H2SO3, because SO3 is sulfite, becomes sulfurous acid. And likewise, HNO2, NO2 being nitrite, will give us nitrous acid. The bases that we will be concerned about in this course will all contain the hydroxide ion, which is oxygen and hydrogen and has a charge of -1. And so you name those bases like any other ternary ionic compound, an ionic compound containing a polyatomic ion. So NaOH is sodium hydroxide, or CaOH2 is calcium hydroxide. The one exception to that is ammonia, which I've already referred to in an earlier video as one of those compounds you just need to memorize, that NH3 is ammonia. There are other types of acids and bases, but they're not covered in this course. So let's get on to neutralization reactions. We've already covered this in talking about double replacement reactions because it is a double replacement reaction. In a neutralization, an acid combines with a base, and as a result, you get a salt, which is just an old-fashioned word for an ionic compound made up of ions, and water. In this neutralization reaction, the properties of the acid and base, the pH of the acid and base, actually goes from being very low for acid or very high for a base into a neutral pH. So it's known as a neutralization reaction because you end up with water, and water has a neutral pH. And the salt does not contribute hydrogen ions or accept hydrogen ions, so it is not involved in pH at all. It does not have a pH. So let's do some reactions and predict the products. Remember, you're going to make an ionic compound and you're going to make water. So if we look at hydrochloric acid and sodium hydroxide being combined, well, water, the formula is H2O. So here's one hydrogen, here's our other hydrogen and oxygen, and what's left over is sodium and chloride, and we know from the periodic table of the ions that sodium is a positive one and chloride is a negative one, so our formula would be NaCl, and we would make a water. And this equation is actually balanced as it sits here. In our second reaction, the acid is acetic acid. See, notice it also starts with the hydrogen. This acetate ion is sometimes also written CH3COO. You will see it both ways. It has a -1 charge, so we only need one hydrogen. It's going to combine with zinc hydroxide as the base. And so again, we have our water coming, the hydrogen from the acid, the OH coming from the zinc hydroxide, and so what's left over is the zinc and the acetate. Zinc, we know from this formula, is a +2 charge. Zinc always has a +2 charge. So we'll have zinc with 2 acetate ions, and I'll just write this way. And then our water. And then, of course, since we have 2 acetate ions, we have to put a 2 in front to balance the formula, and that will give us 2 molecules of water. And then finally, we have sulfuric acid, again, H2SO4, the sulfate ion with hydrogen, and lead hydroxide. So again, the hydrogens and the hydroxides are going to form the water. What we have left is lead and sulfate. We know from this that the lead is going to be a +2 charge because hydroxide only has a -1 charge. And so our lead sulfate will be PbSO4, because we also know that sulfate is a -2 charge because the hydrogen, we need 2 hydrogens to balance it off. And then we're left with water again. And to balance this, we're going to need 2 molecules of water. So you just look for the water being taken from the H in the acid and the OH in the base, and combine the other 2 ions appropriately, paying attention to charges to form your salt. So that's the overview of acids and bases and how to figure out neutralization reactions.